Pluto is a far-off and subtle more unassuming planet that was once a piece of our nearby planetary framework. However, progressing upsetting declarations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They suggested that this distant world is on a potential impact course with Neptune, but how is it that this could truly work? Also, what may be the consequences of such a gigantic event? Are we seeing a confusing gigantic whimsy, or is there something else to this approaching ceaseless mishap? Join us as we look at the likely outcomes of a Pluto-Neptune collision. Pluto, a past planet that was renamed as a dwarf planet, remains a subject of interest in the vast universe as shown by ongoing conjectures by leading subject matter experts. Pluto's orbit is hazardously near Neptune's. Astrophysicists Neil deGrasse Tyson and Kaku are both raising the alarm about a potential danger mishap between these two planets, which could imply a monstrous liability to Earth. However, how is such an event even conceivable? Pluto's journey around the Sun is dissimilar to that of any other planet in our solar system. It requires a stunning 248 years to complete a single orbit. Since its discovery in 1930, it hasn't even completed one full revolution. Anyway, the interest doesn't stop there. Pluto's orbit is marked by its especially curved shape, wandering broadly from the almost round orbits of the major planets. What makes Pluto's orbit much more remarkable is its inclination, which is 17 degrees to the ecliptic plane. The way Pluto follows its path is significantly more unpredictable compared to other planets. This inclination and irregularity add layers of intricacy to its orbital plan. Possibly one of the most fascinating pieces of Pluto's orbit is its convergence with Neptune's. For around 20 years in each orbit, Pluto actually moves closer to the Sun than Neptune, opposing what we could expect from their positions in the planetary system. This prompts the usual inquiry: why hasn't Pluto crashed into Neptune? The answer lies in the gravitational impacts of different planets. The assessment of Pluto's orbit began soon after its discovery. Initially, space experts tried to figure out its unique path. Unlike other planets whose orbits lie relatively close to the ecliptic plane, Pluto's orbit stands out with its steep inclination and erratic shape. The mystery grew with the realization that Pluto's orbit does indeed cross Neptune's. The stability of Pluto's orbit not withstanding these complexities is proof of the intricacies of celestial mechanics. The three-body problem in space involves determining how three objects in space like Pluto, Neptune, and the Sun move and impact each other with their gravity. It's like trying to predict with a high degree of accuracy where they will go based on where they started and how they pull on each other. For Pluto's situation, this issue shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complicated manner. The terms non-simultaneous libration, orbital precession, and VZK wobbling are key to this riddle, as explained by astrophysicists. What keeps all planets in their orbits is non-simultaneous libration concerning Pluto and Neptune. This term essentially means that when Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial division is crucial in keeping their orbits from meeting. Orbital precession, on the other hand, refers to the upward movement of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, adding an extra layer of protection from potential collisions. Another key factor in this situation is the VZK wobbling, named after three scientists, Zell, Kai, and Kaku, who studied how objects move in space. It involves how three space objects like Pluto, Neptune, and the Sun pull on each other with their gravity. This pulling affects how they move. For Pluto's case, the VZK wobbling helps us understand why its orbit near the Sun is so irregular. Despite Pluto's orbit seeming tumultuous, this wobbling helps keep it moving smoothly over stretched periods. The VZK wobbling shows that despite things in space seeming wild and unusual patterns and rules maintain some control, these forces help keep Pluto's orbit stable, ensuring that it doesn't collide with Neptune or veer off course. This three-body problem is key to understanding how these orbits change due to the way space objects pull on each other. Studying this helps us learn more about Pluto, our solar system, and even distant galaxies and their stars. Mathematical simulations in the late 1980s revealed that despite the stabilizing properties, Pluto's orbit is actually irregular with minor deviations in initial conditions, leading to massive differences over hundreds of years. However, these characteristics of Pluto's orbit have been found to maintain stability over incredibly long time scales. Checking the disturbances from later automated assessments has helped us understand how the giant planets like Neptune, Jupiter, and Saturn impact Pluto's orbit around the Sun. Neptune has a unique relationship with Pluto where, for every 2 orbits Pluto makes around the Sun, Neptune completes 3. This relationship helps keep Pluto's orbit stable. However, Neptune is not alone at work. Jupiter's gravity also plays a massive role in stabilizing Pluto's orbit. Saturn too contributes. These studies show that Jupiter's immense gravity is strong enough to ensure Pluto stays on a steady path for quite a while, possibly even for a long period of time. So perhaps Neptune, Jupiter, and Saturn are coordinating to ensure Pluto continues to move safely through space without running into trouble. These peculiarities are crucial for keeping everything in place. Without these mechanisms, the solar system as we know it would be a much rougher place. Bodies like Pluto could crash into others or be ejected from their steady orbit, setting off a chain reaction with other celestial bodies. For Pluto particularly, with concerns about it possibly crashing into Neptune in the future. Understanding its orbit is essential. This gives a clearer picture of the dynamic nature of the nearby solar system. The case of Pluto shows how even the most seemingly unstable orbits can reach a state of equilibrium through the complex interaction of gravitational forces and orbital mechanics. It also highlights the importance of constant observation and analysis of these arities to better understand our place in the universe. Investigating the depth of space often forces us to confront the unusual nature of celestial bodies. Moreover, Pluto's orbit is an ideal example of this anomaly. The concept of orbital chaos, which refers to the delicate reliance of a celestial body's orbit on its initial conditions, is clearly demonstrated for Pluto. This means that even slight changes in the dwarf planet's position or speed can drastically alter its long-term orbit. Using automated simulations has been immensely helpful for researchers in figuring out how Pluto moves in space. These simulations use complex mathematics to model how Pluto and other space objects like Neptune pull on each other. By tweaking small details in the simulation space, scientists can see how even minute changes can create a vast difference in where Pluto ends up. In the late 1980s, these simulations showed something interesting about Pluto's orbit. Despite having features like asynchronous libration and orbital precession to keep it stable, its orbit can still be inconsistent and unusual. If you start with only a small difference in where Pluto is or how fast it's moving, its orbit could end up looking completely different after just a couple of years. Yet despite this chaos, Pluto's orbit remains stable over huge time scales. Like billions of years, this means that Pluto's journey around the Sun has a kind of order to it, even though it appears wild at first. Predicting celestial movements, particularly when they involve irregular orbits like Pluto, goes beyond a massive challenge. Theories on the object's origin and the inherent inconsistency of these systems mean that long-term predictions are often filled with uncertainties, while mathematical models provide excellent tools for understanding and predicting the future movements of celestial bodies. They also highlight the limits of our predictive capabilities. These models heavily rely on the accuracy of initial conditions, and any small error or distortion can lead to vastly different outcomes, making precise forecasts a daunting task. Beyond the chaotic nature of planetary orbits, Pluto reminds us of the ever-changing and dynamic nature of the universe. While we've made tremendous progress in understanding space, Pluto's case serves as a reminder of how much our knowledge of the universe still remains limited. Grasping the gravitational effects of the giant planet on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can significantly affect the stability and trajectory of other bodies within the system. So why are leading astrophysicists recently raising concerns about a potential collision between Pluto and Neptune, despite all these complex forces working to prevent such an event from happening? Neil deGrasse Tyson, a prominent astrophysicist and a major figure in advanced cosmology, offers a unique perspective on the mysteries of our solar system, particularly the intriguing case of Pluto. Tyson, known for his role in renaming Pluto from a planet to a dwarf planet, offers insightful analysis on the evolving nature of celestial mechanics and the public's interest in the forgotten corners of space. Tyson's position on Pluto's renaming is based on the ever-growing understanding of our solar system. He sees the renaming not as a diminishment but as an important adjustment to our developing understanding of the various bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continual learning and change. He views the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. The fascination with these questions keeps the study of space so exciting. However, despite Tyson's optimism, his thoughts on Pluto's potential collision with Neptune paint a different picture. His concerns about the fate of Pluto, once a planet, stem from his understanding of the unpredictable nature of these orbits. Tyson acknowledges that while Pluto's orbit has remained stable thus far, small shifts over time could lead to catastrophic events. The path of Pluto, especially its convergence with Neptune's orbit, is an intricate cosmic dance that may or may not remain steady. In Tyson's view, even small perturbations in Pluto's orbit could have significant, lasting effects. If these shifts accumulate over millions of years, they could eventually result in a more unpredictable outcome, potentially even a collision with Neptune. However, these events would not occur anytime soon. Rather, they would unfold over long time spans well beyond human lifetimes. Nevertheless, Tyson's cautionary stance emphasizes the importance of continued observation and understanding of Pluto's orbital dynamics. Tyson isn't alone in his views. Michio Kaku, a theoretical physicist, also contemplates the potential chaos that could unfold from planetary interactions within the solar system. While Kaku shares Tyson's enthusiasm for exploring the wonders of the universe, he also recognizes the inherent instability of planetary orbits and the unpredictable effects that could emerge over time. Both Kaku and Tyson stress the importance of ongoing research into the forces that govern planetary motion and the future of our solar system. Ultimately, the case of Pluto serves as a reminder that our understanding of the cosmos is ever evolving, and new discoveries often lead to more questions than answers as astrophysics continues to develop. The possibility of an event like a Pluton-Neptune collision reminds us that space is full of surprises, and the seemingly calm orbits of planets can be subject to dramatic changes in the future. These reflections on Pluto remind us of the importance of keeping our eyes trained on the stars and our minds open to the rise that still lie ahead.